Hello, this is Aaron Sirocco, and I will be presenting with Jason Zellers our Arduino project for Chapter 12, which is called the Knock Lock. And essentially, what we did is we assembled the circuit according to the book, used the special sensor called the piezo sensor, and essentially what the project does is once we build it and we complete it, which we'll show in our next steps, we can, so to say, knock near the sensor, and after 3 knocks, the sensor will unlock the door, the lock, or whatever you may call it. And we'll do that using the servo, and once it is unlocked, it'll turn 90 degrees, and we'll explain that more in the next step. But again, to recap, the sensor will turn on, we'll start the program. After 3 knocks, the program will unlock, and when we push our button, it'll lock it again, and we can keep doing that process over and over again. And we'll see you in the next step.
In this section, we'll be talking about the hardware. Fairly simple stuff. We have a switch, an LED, just a light, 3 different kinds of resistors, a capacitor, which you can basically think of that as a battery. It temporarily holds the voltage, the servo motor, and what's called a piezo, which we will be going over in a later section. The other thing we needed to do was called header pins. We needed 3 of them, and that's to go from the servo motor onto the breadboard, because the pins off the servo motor are female, and then the breadboard is a female connection as well. The header pins allow you to connect the servo motor to the breadboard. Now onto the software. As you can see, since we're using a servo motor in our project, we had to include the servo motor code, what we call instantiate or name that code. We called it myservo. Here we created the constants and the pins for what we're going to use. Piezo for the speaker, the switch pin is for the button, yellow LED, green LED, and a red LED. And those are constants, and then we're going on to the variables. The difference is the variables can change values. Knock value is the value that is being read off the piezo. The switch value is the button state, so when you push the button, it'll change that value. Quiet knock, loud knock, so we can compare from the piezo knock value. And then the Boolean locked is to tell the servo motor if it should lock or not, almost like a true or false statement. And then the number of locks is this one. And then onto our setup. We attach the servo to pin 9. We say that we have LEDs connected as outputs, the button as an input, in case we need to print anything to the monitor, and then digital write. We're going to initially turn the green LED onto a on, so we put it as a high. And this would actually write to the servo motor, and initially it's going to be in the unlocked position, and then we're going to print to the monitor that the servo motor is unlocked. So onto the loop. We're going to delay for half a second just to let that servo motor get into position, and then it's initially going to be unlocked, so locked equals false. The switch value is going to just read that pin, or the button, and if it's pressed right here, then we're going to set lock to true, so that's going to move that servo motor to true. Change the LEDs, and this code actually moves the servo motor, and then it prints out to the monitor that it's locked. Once again, wait for a second to let that servo motor move, and then if it's locked, we're going to read the piezo for the knock values and then compare those knock values. If it's greater than 3, or less than 3 or greater than 0, we're going to compare. We'll get into that in a second. And then if it comes back as a good knock, it's going to increment that knock, the number of knocks. And then we're going to print out how many you need to go. And then down here is our method for checking the knocks, comparing what the piezo is picking up to a pre-recorded value. And that's our code.
As you can see here, this is just a software implementation of the actual hardware, and I will show the actual hardware we built in a second, but here's the virtual building of it. And as you can see, we'll start with this pin A0 right here, and what that does is it goes to the piezo, and what that does is it takes the input from the piezo and it sends it to the Arduino, and that's through the analog input. And then depending on what value the piezo sends, it'll send values to the LEDs from pin 5, and that'll go to this red LED. It'll send also information to pin 4, which is this green LED right here. Let's see if you can see that right there. And then pin 3 is the yellow LED right here. And again, we have resistors, just making sure that the LEDs don't burn out and that the battery life is preserved. And this capacitor is, again, just to keep the constant flow of voltage. And right here, this resistor right here is to ground that connects to the piezo, and that's just to make sure that it's connected to ground and gets the voltage that it needs. And then this button right here, that'll be used to reset the circuit. And so what that'll do is once all the knock values are detected and the circuit unlocks, you can hit this button to restart the program, and it'll relock the circuit, and you can keep doing those knocks, and it'll open up again. And this resistor just makes sure that the button receives the proper voltage and logic. And this servo right here, as you can see, this will determine whether it is locked or unlocked. So not only can you tell by this red LED if it's locked, but also if the servo is turned 90 degrees, you'll know that it's considered in the locked state, and then when it turns another 90 degrees, it'll be unlocked. And so it'll just keep going back and forth from 0 degrees to 90 degrees, 90 degrees to 0 degrees, depending on if it's locked or not. And the last thing that needs to be covered is this pin right here, pin 9, and that is also dependent on the piezo input, which goes to A0. And what this does is if the gate, not the gate, but the piezo detects 3 knocks, this pin will send a signal to the servo, which will make it turn. And that summarizes the build section, and I'll show you a couple pictures of our actual circuit. And again, the wiring is really messy just because there's a lot going on, and that's why we made the software implementation. But if you want to see a picture representation of what actually happened, it's right here. On to the extension section. This part of the section basically explains how we can further implement our project into a real-world application, and this would be having our project inside a box and cutting out a little section in the box, which you can see right here, so that when it is locked it can hit something or it can move one way, and then when it's unlocked it moves the next, maybe unlocking something inside the box or turning something on, what have you. And somewhere around here you could cut out holes for the LEDs, so that way you not only can use the servo to tell if it's locked or not, you can also see the LEDs. So this is another way to, I guess, take the project another step. And then moving on to more of the software side of this extensions, this magnifying glass right here pretty much talks about how important functions are and why it's just not a good idea to copy and paste your code. And we'll come back to the code right here at the very bottom. You can see this method right here that returns a Boolean, and that it's called check for knock. And there are many reasons why you just want to use functions. If you've taken CSE 110, you'll understand that more, but essentially you want to use functions as much as you can because it allows you to reuse code, and as you get higher up and as we get into more complex projects, you just can't copy and paste this code into the section you need. And also it provides readability because no one wants to read something that's 3,000 lines long, but if you create a function that essentially does one thing and you return that, not return that function, but you call that function 5 or 6 times, the person doesn't actually need to read that same code 5 or 6 times. If they can understand this function right here, they in essence know what's going on in your program in that section. So for readability, it just makes it really convenient to make functions, and as you'll see in the next coming projects, it'll be really good to use functions just for readability and practical use, so you don't have to keep copying and pasting code. And this last example just says that for each knock, you can count the time intervals between them using the millis function, which would calculate the amount of milliseconds in between them. And that would just need to adjust the code, and you could probably put it in where it has if knock values equals less than 3 and knock values is less than 0. It would be somewhere right in here when it increments. You could put it in right there. But again, you can mess around with that depending on the project. And pretty much that summarizes this extensions. So again, just to do a quick recap, you can create more from this project by making a box, cutting out holes so you can actually see what's going on, the importance of functions and how we'll be using those in future projects and more projects that provide more complex code, and that you can calculate the time in between knocks. And that wraps up this section for extensions.
Now onto the section of special devices. Really the only one we had out of the ordinary was what's called a piezo element. Essentially all it breaks down to is a pressure sensor. And what it does is you hit the top of it and it converts that pressure that you create into a voltage. And that's where we had one of the problems with this project, because no matter what we did, it kept coming back as a bad knock value. And if you remember from our software section, we had specific values for a quiet knock and a loud knock, but it always came back with bad knock values. So we made a test point in our code to see exactly what that value was. It's right here, and it consistently came back at 1023. So we did some research to figure out where that number was coming from, and then through Aaron and I's knowledge of programming and electronics, we were able to find that here is the piezo element, and that 1023 basically represents full voltage. So it wasn't converting. So either the element was bad or one of the wires was bad. And it eventually turned out that it was actually one of the wires was bad. So that was one of the problems that we had with this project. And so in overview, a piezo element is just that, is a pressure sensor. Thank you.
And this concludes our project. And overall, this project tested our knowledge of electricity, programming, the ability to read circuit diagrams from the book, and just overall knowledge of how circuits work, when to use resistors, when to use switches, how to connect the wires to make sure they get the right inputs they need and they output the correct values. And that summarizes what we learned, and the tools we learned we used were the Arduino book. We used the Fritzing software that allowed us to create this digital schematic, and we used the Arduino IDE obviously to create our code. And we also, something to mention is we found a bug in our code, and essentially what it was is once we hit 3 knock values, it would unlock, but our program wouldn't reset those values. So when we tried to reset the program, it would just keep locking and unlocking consistently at a rapid rate, so it wouldn't work. So we had to manually adjust that code ourselves, and we found that out because we want to major in the computer science field, and our knowledge of coding was able to catch that. But otherwise, I don't know if someone who doesn't have an experienced background in programming would have been able to foresee that or catch that. So that is one thing we thought about mentioning in this video, is to be aware of some bugs that come up in the book. You know, it could have typos or maybe just copy something down wrong. So just always know what your code is doing and be able to fix it is a great skill to have. And that wraps up our project. That is Project 12, the knock lock, and thanks for listening.